Children, once again reminding the syllabus of ray optics. First is refraction of light, and we have studied in class 10 that refraction is the phenomenon of change in the path of light when it travels from one medium to another. Since the refractive index of medium are different, so we can say the phenomenon of change in speed of light is also refraction. Let us see here a denser medium and rare medium. Denser medium, you can say a glass of refractive index n. So here when the light is incident, then it bends towards normal while it passes through denser media, and again when it go in the rarer media, it move away from the normal. And the laws of refraction, there are two laws. First law is the incident ray, the normal and refracted ray all lie in the same plane at the point of incidence or point of refraction, means at this point. Second law is the ratio of sine of angle of incidence to the sine of angle of refraction is constant. This law is known as Snell's law, and we know n equal to sine I by sine R at this point. Here n means, see what is the meaning of this n. N say the refractive index of this medium in which refraction is taking place with respect to the medium from where it is coming. Here we have taken the rarer medium as air, whose refractive index is 1, and denser medium whose refractive index is n. So n equal to, actually it is n2, means refractive index of refracting media, by n1, means refractive index of incident media, that is constant, and it is sine I by sine R. Next, now see the total internal reflection. As its name suggests, total internal reflection means it is a reflection, the phenomenon of complete reflection of light back into the same medium for angles of incidence greater than the critical angle of that medium. So here we should know first what is the critical angle for any medium and what is its relation. Let us say rarer medium of refractive index 1, here it is a denser medium, you can say a glass of refractive index n, and a source of light is placed in the denser medium. Now the how light, if light go normal to the surface without any deviation, it will pass. But now see the certain phenomenon. Here see light rarer medium away from the normal. See here what is happening, the angle of refraction, here angle of refraction, here see this is the angle of refraction, here angle of refraction, here this is the angle of refraction. So the angle of incidence at the interface of denser and rarer media, the angle of incidence for which angle of refraction is 90 degree, that angle is critical angle. Once again, the angle of incidence for which angle of refraction is right angle, then that angle of incidence is called critical angle for that medium. Now if the angle of incidence is greater than critical angle, then this angle is greater than, then light, now the angle of refraction must be greater than 90 degree. Then how it is possible? Means light returns back into the same denser media, and this phenomenon is total internal reflection. So on this observation, we can note down some conditions for TIR. First is the incident ray must be in the optically denser medium, or we can say light must travel from denser to rarer media, and the angle of incidence in the denser media must be greater than the critical angle for the pair of the media in contact. Next here see, what is the critical angle? Now take it. It is a relation between critical angle and refractive index. Relation between critical angle IC and refractive index of the media. Here we have taken denser media and light is coming at angle IC. IC is the critical angle. So critical angle is angle of incidence for which angle of refraction in this media it is the 90 degree. Means light just passes over the interface of the media. Then how we can write the Snell's law? N21 means refraction taking place in second media equal to N2 by N1. Now here it is sin IC by sin R, and this is, see, the refraction taking place in the rarer media, its refractive index is 1, and here N1 myself taken, that is the denser media whose refractive index is N. So we can write this N2 by N1 is 1 by N, and it is sin IC by sin R. What is R here? 90 degree. So 1 by N equal to sin IC, or N equal to 1 by sin IC. It is the relation between the critical angle and refractive index. Application of TIR: mirage formation, looming, totally reflecting prism, optical fiber, a sparkling of a diamond. This year optical fiber is in focus. Yes. Now, so these are all about the total internal reflection.